Hello everyone, welcome to another Quad Education Test Prep Fundamentals video. My name is Tom, and today we're going to be talking about a topic from the SAT and ACT that, in my opinion, doesn't get nearly the amount of attention that it deserves. This may be because it isn't the most obvious identity, and also it is kind of difficult, but regardless, it's a tool that I use to tackle some of the most difficult questions on the tests, and one that I hope that you'll adopt into your arsenal as well. That tool and that topic is factoring in perfect squares. All right, let's take a look. So when I say perfect squares, what I'm referring to are three identities that result from multiplying some very specific binomials together. The first involves squaring one number plus another number, which you can see here I've labeled x plus y squared. So when you multiply those two together, you can FOIL this on your own at home, but for the interest of time, I've written it out here for you. What you get is x squared plus 2xy plus y squared. The second identity here is the same thing except one number minus another number squared. So you can see here that that's effectively the same thing when you FOIL it out, x squared minus 2xy plus y squared. And if this feels a bit like word salad right now, in just a minute we're going to go into some specific detail, and so that'll clear it all up. So bear with me just as I define these three topics. And the final topic here is what happens when I multiply one by the other. So something plus something times something minus something. And what I get there is x squared minus y squared. So this property, x squared minus y squared, has a name, and that name is difference of squares. In the interest of time, though, we're not going to talk about that today. We're going to focus on the first two ideas, the x plus y squared and the x minus y squared, but look for a video in the future about difference of squares. All right, back to the blackboard. So, as promised, let's take a look at a concrete example and see if we can't get some context here. So, looking again at our property, x plus y squared is equal to x squared plus 2xy plus y squared. So in this example here, 4a squared plus d cubed plus 3b cubed z, and we're going to square that whole thing. First, we're going to take a look at what the first item is, which is 4a squared d cubed, and we're going to square that. I'm going to add to that 2 times whatever x is, which is our first property, 4a squared d cubed. And then we're going to multiply that by our second property, which is 3b cubed z. And then we're going to add to that, finally, our third property, which is 3b cubed, z. And we're going to square all of that. And so if we just follow our exponent rules, if we square 4a squared d cubed, that's going to be 16a to the fourth, d to the sixth. We're going to add 2 times 4 times 3. That's going to be 12 times 2, which is 24. And then we can't really combine any of those letters, so just write them all out in alphabetical order. A squared, b cubed, d cubed, z, and then, sorry, that doesn't need to be there. And then for the last property, we're going to say that that's going to be 9 b to the 6 z squared. And so that's a nice way to skip a ton of steps just by using this property. I don't have to FOIL this huge thing. I can just write down those quantities. So I'm just going to go ahead and clear that out. And previously I had written this in Word, and that's because my handwriting is pretty bad. So here you can see it typed out in full. And so that's pretty fancy, but on these tests, they don't often ask you to do this. This is just sort of a good demonstration of the topic. What they will ask for you to do is look at it the other way. So instead of taking it in the binomial form and then squaring it, they're going to give you a trinomial and have you recognize that it can go backwards into the binomial squared. So taking a look at these two examples here, we have x squared minus 14x plus 49 and x squared plus 2x plus 1. So take a minute and see if you can't go backwards and move these trinomials into a squared binomial. Okay, did you get it? So for the first one, that's just x minus 7 squared. And maybe we'll do a video in the future about completing the square. But for now, we're just saying recognize that this is x minus 7 squared. And then the second one, that's just x plus 1 squared. Okay, now let's move on to our example problem. So looking at this problem, we certainly have a challenge, and I've labeled this as hard because this is definitely a difficult question. Take a second here to see if you can't figure that out. Okay, let's go through it. So we've got this big scary fraction, and then they ask you, if x is the solution to the given equation, which of the following is a possible value of x minus 6? And whenever you see the SAT asking for two quantities at once, sometimes the ACT does this as well. But whenever they ask you for two things at once, you should know that there's going to be a really clever way to arrive at that property and not find x and then take away 6 from it. So let's take a look. The first big thing is you're supposed to recognize, yeah, x minus 6 is there, and that right there, that is x minus 6 squared. So right away, we're really getting someplace. So x minus 6 squared equals 16. And since we have that square and we don't want it, we can just square root both sides. And so then we're at 1 over x minus 6, and that's equal to 4. And so pretty easily we can do our little denominator flip rule here and just say that this is 1 over 4 equals x minus 6. And in 3 or 4 lines of algebra, we've already gotten to the answer, and that is a quarter. Okay, that's it for this video. Hopefully you've seen some of the interesting and useful applications of factoring that you may see on the test. If you found this material helpful, please consider liking, sharing, and subscribing to Quad Education. Thank you for watching, and I hope you have a great day.